Hello, ladies and gentlemen. It's my pleasure to continue our introduction to matrix algebra by considering some simple economic application of matrix algebra. Economic application of matrix algebra. Let's fix the idea by considering some examples. Example 1, the exports of cocoa in 1,000 USD from Nigeria to Belgium and Canada between 2014 and 2022 are shown in the table below. Let's use matrix subtraction rule to find the difference. Matrix A. The first column of that matrix is exports to Belgium, while the second column is export to Canada. Then we need to create a second matrix B as a column vector of 1 and -1. The -1 indicates that we want to subtract Canada from Belgium. So we need to carry out the multiplication, and this is what I have shown us here. The second question, a rice dealer increased prices of rice brands R1, R2, R3, R4 by 50% at the end of last month. The sales price of rice in his 3 stores, S1, S2, S3, before last month are shown in the table below. We need to find the current prices in those stores. So these are the prices, that is matrix A contains the prices of the 4 brands in the 3 stores. An increase of the price by 50% will be 150 divided by 100, which is 1.5. So this is a typical example of scalar multiplication. So we multiply matrix A by 1.5 in order to get the current price. The third example, a staple food seller sells rice, beans, cassava flakes in 2 shops, and we have the quantity sold, individual prices of the food items, and the cost to the store as shown below. We want to find the store's profit per week using total concept approach and per unit analysis approach. For the total concept, profit is the difference between the total cost and total revenue. Our total revenue is the quantity multiplied by the price, which is shown here. And our total cost is the quantity multiplied by the cost, which is equally shown here. And the profit is the difference between the total revenue and the total cost, which is what is shown here for the 2 shops. In respect of per unit analysis, we can derive our U as the difference between the cost and the selling price. And if you multiply it by Q, then we obtain the total concept again. So we derive our U as the difference between the cost and the selling price. And this is what is shown here. And so we multiply the quantity for the 2 shops by U, and we obtain the same results with the total concept approach. So for per unit analysis and the total concept results in the same results. Now the last question for this part of the economic application, assume that the average annual profit of a small-scale maize farmer are 200,000 to 10,000, 2,000 and 4,000 to 5,000 from 2019 to 2022. I want to estimate the average annual profit for 2030. This is the linear equation we want to estimate. And the This is like estimating a linear equation y equals to ax plus b. And we are given our x now at 0, 1, 2, 3. And the coefficient of our b, which is intercept, will be 1, 1, 1. So we have our x to be 0, 1, 2, 3, 1, 1, 1. So we obtain the transpose, and we obtain the inverse after multiplying the transpose with the original matrix, and multiply by the transpose and multiply by y, which is the formula for obtaining the coefficient of the regression. And at the end, we obtain our b to be 3.9 and 201.4 as our equation. And so the equation is y equals to 3.9 x plus 201.4. And the value for 2030, let us not forget that for 2022, the value of our x is 3. So which means by 2030, the value will be 11. So we multiply 3.9 by 11 and add 201.4 to it. So if we carry out that calculation, that will be our value for 2030. So that will be the profit. Quickly just do the calculation. So this is just simple examples of how to apply matrix algebra to some economy problem. In subsequent video, we shall continue to look at other examples, such as application to input-output models, application to linear programming, and lot more. Thank you. As you continue to watch the video and subscribe to some of these videos.